Yeah, good morning everyone. Myself, Mr. Sankur Naresh, Associate Professor in Civil Engineering Department, Anurag Engineering College. Today I would like to discuss about estimation of steel quantity in the slab. So that is a thing that here first of all I want to give the importance of to design the quantity of the steel because actually the slabs are constructed with there is a reinforced concrete. The concrete actually generally we can call it is in a plain concrete, reinforced concrete. Likewise there is a different types of concretes is there. So what is reinforcement concrete? It's in a combination of there is in a concrete and as well as the reinforcement inside. Reinforcement is nothing but generally we can call them iron rods in outside. That non-educated people they call it is in a iron rods, but here in our civil engineering terminology we can call them it is in a there is in a steel. So here today we'd like to learn about the design of that means estimation of steel quantity in the slab. So here if you see here the problem is given to estimate the steel quantity in the slab, and I want to read out the problem. Later I want to go for a summarize that what are the things are given and what are the things are is missing in the problem. So then here if you observe the problem, the reinforced concrete slab has been following the specifications, and that means the slab is constructed with a reinforced concrete having the length so 6 meters and width 4 meters and the thickness is 150 mm. And if you see that there is a main reinforcement 12 mm diameter bars at the rate of 150 mm center to center spacing. That means if you provide any main reinforcement bar, we are going to be placing that there is the spacing between the 12 mm bar to 12 mm bar we need to provide at least 150 mm center to center spacing. And similarly distribution reinforcement is 10 mm diameter bars and at the rate of 200 mm center to center spacing is given, and clear cover is also given. There is a 20 mm on all sides. Now that one more thing is going to be missing here, that is here there is a unit weight of the steel they want to specify, but generally as per the steel codal provisions we are going to be taken that definitely this densities may varies from one size to another size. So now finally what happened, if you want to design the quantity of the steel in the slab, first we should know that the dimensions of the slab LBH, then length and breadth and thickness, and then similarly the spacing is needed from center to center, and a clear cover is also needed. So then we should also know that what type of bars are existed in the slab, that is also should be known for us. So that is in a problem is given. Now I would like to explain how to calculate the steel quantity, that one by one we'll see that in the problem statement. So if you see that that's a main quantity main reinforcement quantity calculations. So how can we calculate the quantity? First of all, first we need to calculate the length of the one bar, and then later we need to calculate the number of bars required for the specified dimension, and then we need to multiply the this number of bars with length of the one bar, and then if you want to calculate the quantity of the steel in terms of kgs, just you can multiply with the unit weight of the steel with that. Similarly here also that same thing is given. For example, if the main reinforcement is given, so the main length of the one rod is equal to width of the slab minus 2 into clear cover, because if you take in a slab in a width wise, so we are going to be leave one cover in one side and one more cover on another side, so that we are going to be take 2 here clear cover, so that you know what is the width of this slab as per the problem statement. It's in a 4 meter, so 4 meter minus 2 into there is in a clear cover it is given, it's in a 20 is given, so that we are going to be converted into in terms of meters. So that is a 2 into 0.02 meters. Therefore that length of the rod is equal to 3.96 mm. And similarly, how can we calculate the number of bars here? So we had in a formula that is equal to length of the slab divided by spacing whole plus 1. That means length of the slab divided by spacing whole plus 1, it will give the number of bars. And similarly here the length of the slab, that is equal to 6 meters, is given in the problem statement, and divided by spacing for this slab. That means here it is in a main reinforcement. If it is in a problem statement, is given it is 150 mm, so that we need to convert it into in terms of meters. So that 6 by 150 mm, if we convert it, is 0.15 meters whole into plus 1, that is equal to, you may getting the answer, that is in a 41 bars here. And then if we see that that length of the total length of the bars, so here we are calculated there is a length of the 1 bar, and then we are calculated number of the bars. So the total length of the bar is equal to, so that is equal to 41 bars multiply with the length of the 1 bar, so that you got 162, that is equal to 41 into 3.96 is equal to 162.36 meters. So this much length of the bars are needed to to placed in a slab. So that if you want to calculate the quantity, so if you want to calculate the quantity, so that is equal to total length multiply with the unit weight. So here unit weight taken in the problem, I already told that it is not given in the problem, but here they may taken 0.888 kg per meter cube. That's a value they are going to be taken. So that here there is an answer is 144.19 kgs of steel reinforcement needed. So this is only for the main reinforcement. So after getting that, if you want to calculate the cost required for it, then 1 kg of steel is equal to around, and then you can multiply the 1 kg of steel with this 144.19, so that you got any cost of the main bar. And then if you observe that next there is it's in a summary is given. So what are the things are given? Length of the 1 bar is equal to 3.96, and the number of bars what we are calculated, it's in a 41, and then total length of the main bars is equal to that 162, and the weight of the steel is equal to 144. Then if you want to calculate here the cost, maybe for example if you take it is in a 1 kg of 1 kg of steel around there is in 100 rupees, if you take an example. So that cost of the main bar is equal to 144.19 into 100, therefore 14,000 490 rupees is a cost of the main reinforcement. So if you know these cost details, it's very helpful for your any builder or constructor or whatever they want to design it. So like if you see that this is the only main bar till now I am discussing. And the next one I want to discuss about, there is a distribution reinforcement. If you see the distribution reinforcement, and here also similarly if you observe that the length of the 1 bar we are calculating, how can we calculate the length of the 1 bar is equal to, so length of the slab. So if previously we are taking the width of the slab, and now we are taking here length of the slab. So length of the slab minus 2 into clear cover similarly, but length of the slab is equal to, as per the problem statement, it is 6 meters minus 2 into the cover is 20 for all sides, so that we can convert it into in terms of meters. Therefore 6 minus 2 into 0.02, that is equal to length of the 1 bar is equal to 5.96 meters. And similarly we are also going to be calculate the number of bars, so that is equal to width of the slab divided by spacing all plus 1. So that is the width of the problem as per the problem statement is given. There is in a 4 meters divided by that spacing. Actually if it is in a distribution bar, the spacing is given 200 mm, so that we need to convert it into in terms of meters whole plus 1, that is equal to 21 bars are we have getting from that calculation. And now there is a total length of the bar. How can we calculate the total length of the distribution bars? That is the number of bars, okay, number of bars multiply with the that length of the one bar, that is equal to 21 into 5.96, that is equal to 125.16 meters. So the weight of the steel, how can we calculate here? The weight of the steel is that similarly the total length of the bar, distribution bar, multiply with the unit weight. So definitely here what is happening, the problem statement, they are giving the two different unit weights here. So if you observe that previously it may taken 0.888 kg per meter cube, and now it is if it is in a distribution bar, they are giving the 0.617 kg per meter cube. So that if you multiply this value with the total length of the main distribution bars, you may getting the total weight in terms of kgs, that is equal to 77.17. And similarly if you this is a way. So I want to tell one more thing. The first of all, we need to calculate the length of the one bar distribution bar, and then we need to calculate the length of the there is a number of the distribution bars, and total length of the distribution bar, and weight of the distribution bar. And similarly I said that, but one thing we can observe here, that very important. So while we are calculating the length of the distribution bar, here we are taking that length of the slab. Actually the main bars are that means the distribution bars are provided perpendicular to the length of the slab, so that we are going to be take the length of the bar, so that we are going to be taking, this is a number of bars required. So that means what I want to tell here, the distribution bars are placed perpendicular to the length of the slab, perpendicular to the length of the slab, so that we are going to be get the length, and the number of bars is equal to that width, slab width we are going to be taken, that is the width divided by spacing, that is we are going to be take that one. And now similarly if you see that there is a summary is given in this thing for the distribution bar, that is equal to distribution reinforcement. So that is equal to length of the one bar we are getting from the calculation, that is a 5.96 meters, and number of bars is equal to 21, and the total length is equal to 21 into 5.96, we are getting 125.16. That is in a total length we are getting, and the weight we are getting the 77.17. so that if you see here the total quantity of the steel, so the total quantity of steel, if in the case of the main bar we are getting that 144.19 kgs, and if in the case of the distribution bar we are getting that 221.36 kgs. So that finally if it is in the case of the distribution bar we are getting the 77.17 kgs. So if it is in a distribution, total weight is 221.36 kgs. So here I want to estimate the cost of the steel reinforcement. You take that maybe it is in 100 previously, similarly here also you can take it, so there is an 100, so that you are getting that there is an 20 there is in a 22,000 we are getting the value, that is the cost of the total reinforcement. For example, kg is equal to 100, so 220 kgs is equal to, so 22,136 rupees we are getting the cost. And now in a similar way, if you see that the final answer of the slab quantity is required, and then if you see here there is an the arrangements of the bar as per the details is given. So the main bars and distribution bars, so always the main bars is provided along with the width wise, but always the distribution bar provides always with the length wise. So likewise we have should know that the spacing also we should follow it. And finally if you see that this is an arrangement we can done, after done this arrangement only we are going to be pour the concrete in the slab. That means before going to be cast the concrete into this reinforcement, we should check that whether the slab details are is given perfectly or not, or otherwise it may lead to creating the problem, maybe structural failures it may takes place. That's why. And also if it is in a engineering oriented works, and also we are going to be know that there is the size of the bars they are going to be utilized or not. Likewise, we are going to be find out all the details before going to be cast the concrete, and finally we are going to be conclude it. And then now what happened, we are going to be see this figure, we can understand how can we arrange the main bars and distribution bars. Okay, likewise we have any things are there. So now we should understand about this one. Any queries you can ask me after see my videos. And thank you for see my video. And this is about the calculation of steel quantity in the slab. In further classes I want to discuss about maybe the quantity of steel quantity in the maybe beam and column. Likewise I want to discuss. Now thank you so much.